parentheses in the problem, the first thing we want to do is use the distributive property. So we're going to distribute that 3 in, okay, which is going to give us 6x minus 15 plus 5x equals negative 4. Okay. The next thing we're going to do is we're going to collect like terms. So if you see, I have a 5x and a 6x. So when I add those together, I get 11x minus 15 equals negative 4. Then I add 15 to both sides, and I get 11x equals 11, and I'm running out of room, so I'm going to move that over here. And then you divide both sides by 11, and you get x equals 1. Important thing to remember is whenever you see parentheses, you have to do the distribution first. And then if you have a situation where you have like terms, then you collect all your like terms first, and then you solve it, or not first, second you collect like terms, then you solve the equation in a normal way. Another one, we have 2 sets of parentheses, so I'm going to have 2 distributions. I'm going to distribute in the 3, and then see how this is minus 4? That negative has to stay with the 4, so I'm actually going to be multiplying each of these by negative 4. So don't leave that negative behind. That's really important. Okay, so I get 3x minus 6, and then I get negative 4x minus 12, because negative 4 times positive 3 is negative 12. Okay, I have 2 sets of like terms. I have a 3x and a negative 4x, and a negative 6 and a negative 12. So my 3x and my negative 4x gives me a negative x, and negative 6 and negative 12 is negative 18. Okay. I'm going to add 18 to both sides, and I get negative x is equal to 37. That's a really awful 3. Okay. Now I have negative x equals 37. Okay. Here they're saying divide both sides of the equation by negative 1, which you can do to get rid of that negative. And that gives you x equals negative 37. But if you don't want to do that step, if I just have anything, negative x equals 12, you just change both signs. If I had negative x equals negative 2, I change both signs. Okay, so you can either do the step of dividing by negative 1 or just change both signs. What's my first step? Distribute. Okay. So I have negative 6x plus 10, right? Because I'm multiplying in that negative 2 is equal to negative 26.
Something will never change.
Subtract 10 from both sides. I get negative 6x is equal to negative 36. Divide both sides by negative 6 and you get positive 6. Okay. Questions on that one? Okay. I'm going to do distributing in my 3. So I get 6x plus 18 plus 4x is equal to 78. And then I have like terms, right? So I have 4x and 6x. That's 10x plus 18 equals 78. Subtract 18 from both sides. 10x is equal to 60. Divide by 10, and you get x equals 6. Again. Okay, for our next problem, I'm going to distribute in my 4. So I get 4x plus 20 plus 5 is equal to 9. I have like terms of 20 and 5, so that's 4x plus 25 equals 9. All right, I'm going to subtract 25 from both sides. And I get 4x equals negative 16. Divide both sides by 4, and you get x is negative 4. And for my last, I've got two things to distribute in, the 5 and the 3. So 5x minus 10 plus 3x plus 3 is equal to 1. And this gives me two sets of like terms. 5x plus 3x is 8x, and then negative 10 plus 3 is negative 7. That equals 1. I add 7 to both sides. I get 8x equals 8. If 8x equals 8, what does x equal? Yeah. Yeah, thank
5
you.
points.
So first we're going to distribute. Okay. Then we're going to collect our like terms. I've got 5x and 6x. So that's 11x minus 15 is equal to 10x plus 1. Now I have x's on both sides. Now the first method that we can use is we can subtract 10x from both sides. Which gives me x minus 15 is equal to 1. And then I add 15 to both sides, and I get x equals 16. Okay, this is method 1 basically. X's from both sides gets confusing. So I have another method. So you do the initial distribution the same. Okay, so we distribute. Okay, and then we collect like terms. So I get 11x minus 15 is equal to 10x plus 1. Okay, but instead of subtracting from both sides, because sometimes that can be confusing, the other thing you can do is you can actually physically pick this up and move it. Now if you move from one side of the equation to another, you change the sign. So change side, change sign. And so for some people, for some reason, it's easier to think of it that way. So I move all of my x's to the same side. So I just picked it up and I moved it, and now it's negative. Then I can combine them and solve this, my normal way. Okay, and it doesn't matter actually if you move everything. What you're wanting to do when you have variables on both sides of the equation, you want all of your variables on one side, so x, you want all the x's on one side, and you want all the things that are not x on the other side. So you can pick these up and move them to put it to the same side, or you can subtract it from both sides, or add, if it was already negative, you would add. Whatever makes the most sense to you. And you don't have to move the 10x. You could have moved the 11x over here too. It doesn't matter which side you go to. That's a preference. I tend to move all my x's to the left, and all my, the left, and all my numbers to the right, but that's just me. There's a time when you might want to move your variables to the right. I'm going to distribute this -3 and this 4. So I get -3x minus 24 plus 4x plus 36 equals 2x. I'm going to collect my like terms. And I'm going to get x plus 12 equals 2x. Now if I subtract 2x from both sides, then there's nothing left over here, right? Since x is by itself, or 2x is by itself, sometimes it makes more sense to subtract this one from both sides. And I get 12 equals x, which is the same thing as x equals 12. All right, so we're going to distribute first, right? We're going to distribute this 4 and that -3. Don't forget to negative. So I get 12x minus 20 minus 3x minus 15 is equal to 8x plus 2. Okay. Then I collect my like terms. I have 12x and -3x. I have -20 and -15. So I have 9x minus 35 is equal to 8x plus 2. Now, opinions. Would you prefer to move the 8x over or subtract it from both sides? Anybody have an opinion? Nobody cares?
Oh.
Either way,
All right, well, this one I'll subtract. Okay, so I get x minus 35 equals 2. Then I'm going to add 35 to both sides. And I get x is equal to 37. Equations involving absolute value. Okay, absolute value is the distance from 0. And distance is always positive. Oh, yeah, that's not a good color. Okay, right? Because it doesn't matter if I walk 10 feet forward or if I walk 10 feet walking backwards. I still walked 10 feet, right?
yeah.
Doesn't matter which direction I went. It's still 10 feet. So distance is always positive. Absolute value is these two straight up and down lines around a number or a variable. Okay? So if I have the absolute value of 2, that's 2. If I have the absolute value of -2, it's also 2. Because absolute value is always positive. Okay? And it's because of the distance from 0. That's what it means. Absolute value means how far are you from 0? Okay? So if we're going to simplify this,
Are you recording?
yeah. If we're going to simplify this, I first do what's inside. So I end up with 2 times the absolute value of 3 minus 8 is -5. So the absolute value of -5 is 5, so I get 2 times 5, which is 10. So we'll have, 2 minus 9. So I have 4 times the absolute value of -7, which is 4 times +7, so that's 28.
So you basically just use the same number,
Just positive.
just make it positive.
Mhm.
Negative. What is positive? You
It's
just
also
keep it?
positive.
You just keep it?
Yeah. So here I have -5 times the absolute value of 3 plus 5, so that's 8. The absolute value of 8 is just 8. So I have -5 times 8, so I have -40. Now you can get negatives if there's an absolute value in the problem, but only if the negative's outside. Right here, this negative is outside, so it's not affected. I've got 4 times the absolute value of 2 plus the absolute value of 3 minus 8, so that's -5. So that's 4 times 2 plus 5, So that's 8 plus 5, so that's 13. Here I have minus and negative, so that becomes positive, right? So I have 6 times the absolute value of 9 plus 5 minus 10 is negative 5. So I have 6 times 9 plus 5, so that's 54 plus 5, so that's 59. If the absolute value of 7 is 7, and the absolute value of negative 7 is 7, right? If I say the absolute value of x is 7, that means x could be either this 7 or it could be this negative 7, couldn't it? So anytime you have an absolute value of x, you have two answers. So we're going to solve this. You solve it the same way as if this absolute value isn't here until the very, very end. So first we're going to subtract 5 from both sides. And so I'm going to have 4 times the absolute value of x is equal to 8. And then I need to get that by itself, so I divide by 4. So I get the absolute value of x is equal to 2. That means x equals 2 or negative 2. Because if I plug a 2 in here, I get a positive 2, and if I plug a negative 2 in here, I get a positive 2. Okay? Now, if this were to happen, if I got the absolute value of x equals a negative answer, there's no solution, because absolute value is never negative. So if you get an absolute value and you get equals negative, this is your answer. Okay? So once you get this absolute value of x by itself, you just write the positive and the negative of whatever number this is. Does that make sense? Oh, wait. I don't know what I'm doing. I'm going to subtract 4 from both sides. And I'm going to get 2 times the absolute value of x is equal to 14. I'm going to divide by 2. So I get the absolute value of x is equal to 7. So x is equal to 7 or negative 7.
Do you have to write that every time you
This
write down answers?
right here? Yeah, you have to put down both answers. Anytime you see absolute value, you're going to have two answers. So that it kind of, you have 2 bars, 2 answers, if that helps. Do the harder one. You already know how to do the easy one. That's easy.
Yeah, right.
Negative 3 times the absolute value of x is equal to negative 9. And now we said absolute value can't be negative, right? But I still have this here to deal with. So I'm going to divide both sides by negative 3. And a negative divided by negative is positive. So I can do this. So x equals 3 or negative 3. Let me do this one really fast too. If I subtract 9 from both sides, I get 4 times the absolute value of x is equal to negative 17. If I divide by positive 4, that's still a negative number, right? This can't happen, so your answer, if that happens, is no solution. You have to get the absolute value by itself. Okay, do you find? So I'm going to subtract 5 from both sides. Okay, which gives me the absolute value of 2x minus 8 is equal to 16. But remember how I said whatever's in the absolute value can equal the positive or the negative? So you take this right here, that 2x minus 8, I blocked out the 2, and you set it equal to positive 16 and negative 16. You split it. Then you solve each of these. That's 24, so x is 12. And you get two solutions. You get x equals 12 or negative 4. Okay, so whatever's inside that absolute value, you split it into two equations, one with the answer positive, one with the answer negative. Okay, so I have a positive and a negative. And then I solve each individually. So my solution is x equals 3 or negative 7.